Hello, Professor Zoo. My name is Dustin Phan. My partner's name is Galich, and this is our presentation on Project 4 scheduling algorithms. We'll be going over how to compile and run all the scheduling algorithms that you discussed in class, as well as prove that they actually work as intended. So with that out the way, let's get started. Just to let you know, I am running this on a Linux system, which may differ from any other system, but generally, I think the steps should be alright. Regardless, first thing you're going to want to do after extracting all the files is to go to where all the Java files are being stored and copy the path. Once you do that, we're going to go into the terminal and change the path to that terminal. Afterwards, you're going to compile the driver file, as that's where all the code is run, which should compile every other file. So javac driver.java, and as you can see, it's all compiled. Afterwards, you're going to want to run the code. Now, I'm going to show the driver file real quick. The only inputs, it takes two inputs. It's Java driver, and then the algorithm you want to use, and it has to be FCFS, PRI, or RR. Anything else, it will just print invalid algorithm. And then a schedule, which basically is a text document containing the task number, the priority, and how long it should take. With that out of the way, we're going to be using the schedule.txt file, as it has a good variety of priority times and burst times to test everything. If the first come first serve algorithm works correctly, it should just do everything in order. So T1, T2, T3, all the way to T8. And so let's try that. It's going to be Java driver, first come first serve, and then schedule.txt. And if we look at the outputs, we see that it does work as intended. T1, T2, T3, all the way to T8. Now, priority sorts everything based off of its priority number from high to low. So we should expect to see T8 one first, then T4, T5 because of the 5, then T1, T2, T3, and T7, and then T6. Either that or I got the numbers wrong and it's actually from low to high, which in that case reverse the numbers. So let's run it. Java driver priority and then schedule.txt. If we look here, yeah, it does run from high to low. So T8, T4, T5, you get the general idea. I'll scroll through this slowly and you see it works. Red Robin is different on the other hand, as it doesn't complete a task first before moving on to the next, but instead only does part of the task based off of the time quantum. We set the time quantum to about 10, so if we look, it does T1, it should take 2 attempts to finish this. It'll do the first 10 seconds and then the next 10 seconds, similar to 3 times for T2, T3 3 times, T4 2 times. You get the general idea. Now we're going to be running the code now to prove that. Java driver red robin schedule.txt. As you see, the code works. Let's scroll to the top here. And if we look at here, it does run T1 again. This is just, the burst means how much time is left. So it does the first, says we have 20 burst time left. Next time you see T1, it says we have 10 burst time left. And if we move back, attempt to find another occurrence, you see it skips from T8 to T2, meaning that it already completed the burst by this point in time. And generally you should see that trend in every other task. I'm not going to go through it all because that would be cumbersome, but you can see that it does work. And with that, that should be everything. Thank you for listening to my presentation. And it's Thanksgiving break. Hopefully you deserve the break. Have a nice day, Professor Zoo. Bye.